Modern measuring technology has become an indispensable part of production processes today. It's used to control, adjust and monitor various steps in the different processes. And without measuring technology, it would be almost impossible to achieve improvements in quality and growth in output. Heavy industry also uses measuring systems. Working under extreme production conditions, they help to measure physical influences on the material during the rolling process. This film shows various IMS measuring systems, or gauges, as they're more commonly referred to in the industry, used in various production lines, in hot and cold rolling mills, in the steel and aluminium industries. The company Salzgitter Flachstahl GmbH is a member of the Salzgitter Group, one of the leading steel technology companies in Europe. Here at its location in Salzgitter, the company manufactures flat products in its hot wide strip mill using the latest in plant technology. IMS supplied the gauging equipment. Heating furnaces with a total capacity of 240 tons per hour heat the slabs to a temperature of about 1250 degrees. The steel reacts with the air and oxidizes immediately on being removed from the furnace. This layer of oxide is removed in a high-pressure water descaler in preparation for the slab upsetting press. The slabs are measured and checked by IMS non-contact gauges throughout the complete production process. A width gauge in front of the 4-high roughing stand measures the width of the slabs on their forward and backward passes. The thickness profile of the transfer bar is measured for the first time at the entry to the finishing mill. At the exit from the finishing mill, 2 redundant thickness gauges measure the rolled thickness of the strip leaving the mill. The gauge also measures the flatness of the rolled strip. Final measurements of thickness, profile, width and strip flatness are carried out before the coiler. Depending on the target width required, the slabs are upset with an upsetting force of up to a maximum of 22,000 kilonewtons. In the 4-high stand, the next stage in the process, the strip thickness is reduced in several passes. The hot width is measured directly before the reversing stand. This gauge is located in a measuring house situated below the pass line. It's become possible, with a great deal of technical endeavor, to keep the strip edges free of cooling water and steam. Only as a result of this is it possible to determine the positions of the strip edges by measuring the infrared radiation from strip. This is done by 2 moving CCD line scan cameras mounted on a linear unit. They are positioned at the new target width for each forward pass. The measured data from this width gauge is required for width and other adjustment processes in level 2. The same data is also used for pre-adjustment of the stand width. The material becomes thinner with each pass. A thickness gauge in front of the finishing mill checks the entry thickness. The transfer bar enters the 7-stand finishing mill at temperatures of more than 1000 degrees. Exit speeds of up to a maximum of 20 meters per second are reached depending on the material. All the process parameters are monitored closely at the control pulpit. Monitors show all the relevant measured results continuously. IMS gauges for thickness and strip flatness are installed in a measuring house located at the exit of the finishing mill. The C-frame is suspended from an overhead drive system and is driven into the mill measuring position by an electric motor. In order to withstand the high temperatures involved, the C-frame is cooled with water. All the media in the C-frame are monitored. The thickness gauge works on the principle of radiometric absorption. An X-ray or isotope source emits radiation, which travels from the source through the object being measured to a specially developed type of IMS detector, the ionization chamber. En route, the radiation is absorbed by the material. The thicker the material, the greater the amount of radiation absorbed. The measured current flowing in the ionization chamber is proportional to the incident radiation and can therefore be used as a measure of the material thickness. An X-ray tube is installed in the bottom arm of the thickness gauge C-frame. 6 detectors are installed in the upper arm. From a local panel situated near the C-frame, the complete operation of the C-frame can be controlled. When the C-frame starts moving, the door opens automatically and allows the C-frame to drive to the mill measuring position. In the mill measuring position, the center thickness of the strip is measured along its length. All the measured data is stored and logged in full in the Mavinet computer system. A range of monitor screens provides quick and reliable information on the current measuring process. The top part of the measuring house is equipped with the strip flatness gauge top plan. The optical components are easily accessible. The connectors just have to be pulled off and the quick release clamps released. Removing the protection head reveals the projector. Access to the camera is obtained in the same way. The topometric strip flatness gauge top plan is extremely easy to install. In this particular application, the camera and projector are inclined at an angle and integrated in the floor of the measuring house. A special lantern slide in the projector projects a pattern of lines onto the material, which is filmed by the CCD matrix camera. During production, off flatness in the strip leads to distortions in the line pattern, thus allowing the strip flatness to be calculated. This line pattern projection enables a three-dimensional continuous presentation of the strip surface to be displayed over a large area along the length and width of the strip. After being cooled in the cooling section, the strip is measured again a few meters before reaching the underfloor coiler. The measuring house is equipped with flatness, thickness profile and width gauges from IMS. The profile gauge C-frame is suspended from an overhead drive system. 4 X-ray tubes in the upper arm of the C-frame provide the necessary radiation field. In the bottom arm of the C-frame, 98 ionization chamber detectors are arranged in line in a very confined space. The vertical section of the C-frame houses high-voltage generators, measuring transducers, as well as interbus and monitoring components. For cooling the C-frame, the surfaces facing the material being measured are lined with water jackets. The 8-ton C-frame is driven along the transport rails by an electric motor. The gauge simultaneously measures the strip cross-thickness profile and the strip width. Thanks to the staggered arrangement of radiation sources and detectors in strip flow direction, the gauge is also able to measure the strip contour, in addition to the strip thickness profile. For complete scanning of the strip, the C-frame oscillates at a constant frequency of 1.25 Hz. The 4 exit slots for the X-rays can be seen here. The C-frame is made to oscillate continuously by the operation of the pendulum drive. A width gauge is installed at the top in the measuring house. A light source ensures adequate exposure of the CCD line scan cameras. An IMS flatness gauge is installed directly next to the width gauge. In this configuration, the camera and projector are arranged one on top of the other. Due to the air conditioning in the measuring house, no additional housing is needed for the optical components. The measured data from the two flatness gauges, located at the finishing mill and at the coiler, are analysed jointly in the IMS computer system Mavinet. All the data records are stored in the archiving system Mavinet Q for quality management purposes. Finally, the hot strip is wound into coils weighing up to 30 tons.